Your quiz is Friday. It's just over these last two sections of the chapter. All right, so basic foiling, foiling of special cases, and then using special cases to multiply numbers. All right, so we're going to go over a couple of each type, and then I'll let you work. Let's look at this first one. This first one is just foiling. So all you're doing is basically repeated distribution here. You're going to take your 8x, and you're going to multiply through to each piece of that second binomial. So 8x times 3x, remember that is 24, and x times x, your exponent goes up, x squared. Then we have 8x times 6. That's going to give us our 48x. 7 times 3x, that's 21x. And 7 times 6, that gives us our 42. At this point, we want to simplify and make sure it's in standard form. 24x squared goes first. Our 48 and our 21 give us 69x. And then our 42 does not combine with anything, so this would be our final answer right here. All right. The reason I chose the second one is because there is a negative, so pay attention to your positives and negatives. I have 7n times 5n, that is 35n squared. 7n times 2 is 14n. Now I am multiplying negative 2 times positive 5n, that's negative 10n. Negative 2 times positive 2 is negative 4. So remember, to determine if it's plus or minus in between your terms is whether or not your term is positive or negative, all right? And then we're going to do the same thing we just did. Standard form, 35n squared. We do have a positive 14 and a negative 10. So when we combine those two, we are going to end up with a positive 4n. And then this is a minus 4 at the end. And that is my answer. I am finished with that one. All right, so remember, we're just doing our first, our outer, our inner, and our last terms. Repeated distribution there. Flip the page over, we're going to look at special cases. There are two types of special cases. Keep in mind, if you forget them, you can always foil them if you want to, okay? But not foiling them gives you a little bit of a shortcut. So if you have something like this first set, the same exact terms, but it's a plus or minus, these are called conjugates. And your shortcut here is to square the first one minus the square of the second one. So I end up with 25 minus 36k squared. And that is my answer. If I were to foil that, my inner terms would cancel. Okay? So my outer and inner terms are going to be the same, just negated, and they would cancel. And I would be left with my first term squared and my last term squared, always subtraction there. All right, the next one is also a special case. All right, this second one is also a special case. All right, so with this one, remember you square the first term. This next one is always going to be plus or minus based on whether or not that is a plus or minus. So this is going to be a plus. We have 2 times our first term times our second term. And then the last term for these will always be plus because it is the last guy squared. All right. Again, if you want to set it up as foiling, just remember that it is 6n plus 4, 6n plus 4. All right, this is just the shortcut. When I square this, I get 36n squared. When I have 2 times 6 times 4, that's 12 times 4, I have 48n, and then 4 squared is 16. And I am done with that one. So if you have a number squared, then it's going to be like that second one we just did. So I'm going to split this up into a really easy number plus whatever's left over. So I'm going to basically split this up into a multiple of 10 and then plus or minus whatever's going on there. So I'm going to split this guy up to 50 plus 3 squared. That's 53 squared, right? Okay, and this is just like the special case I just did, all right? Which means I do my first one and I square it. Then I'm going to add, since I added here, 2 times 50 times 3. And then I'm going to add 3 squared. All right. If you wanted to at this point, you could do this guy right here. All right. What you may not do is this. All right. Okay. This is algebra, not 3rd grade. All right. So I know you all know how to do that. I am trying to force you to use special cases here. All right. As much as you dislike it, I know. But I'm trying to help you do mental math, okay? Because here's the thing. With this is what they teach you with multiplication, and I know you all know how to multiply, okay? I have no doubt that you know how to multiply. What I'm trying to force you to do is I can give you that answer in my head without a piece of paper. You know why? Because 50 is easy to square. 2 times 50 times 3 is easy to do. 3 is easy to square, and then I have 3 pretty easy numbers to add up. Okay, so I'm trying to get you used to that process so that you can do mental math without like long multiplication. Long multiplication will always work. This is just a different process to try to think about differently. Okay, so had this been like 57 instead of 53, I would probably do 60 minus 3, right? Because it's closer to it. However, if you wanted to, you could do 50 plus 7 if you wanted to, okay? I typically do it to the closest whole, so I have a smaller number that I'm multiplying and a smaller number that I'm squaring, okay? But if you always want to do addition, you can always do the 10 value of 10 and then plus. It will work both directions. So now, once I have this, I am going to square 50. When I am squaring a multiple of 10, I square the first guy, that's 25. And then because it's squared, I have 2 zeros. All right? Then I have 2 times 50. What is 2 times 50? 100 times 3. So I have 300 here. And then 3 squared is 9. So I have 2,500 plus 300, that's 2,800, plus 9, that is 2,809. And that is 53 squared. So for this one, it is not the same number squared. So it's not going to be the case where you take the same exact thing and multiply it by itself. These are going to be 2 different things, but it is still a special case. You will notice that both of these numbers are exactly 2 away from a very easy multiple of 10, right? So I would rewrite the first one as my multiple of 10, plus or minus, depending on which is first. In this case, it's plus 2. So everyone would agree that 82 is 80 plus 2. That's pretty straightforward. Which means that 78 is going to be 80 minus 2. Also pretty straightforward. This is a special case, and this one's actually even easier, okay? This one is my first one squared minus my second one squared. This is where the middle terms cancel out. So for this guy, I would take my first one, and I would square it. And then I am going to subtract from that my second one squared. Remember, these are always subtraction when it's a conjugate, plus minus of the same 2 numbers. Again, when you square a large multiple of 10, square the first guy. 8 squared is 64. And then have 2 zeros, because I squared it. Minus 2 squared is 4. 6,400 minus 4 is going to be 6,396. And that is what happens when you multiply 82 and 78. Okay? By the way, that's much faster than long multiplication. Much faster than long multiplication there. That's where the special case is created. I have the same 2 numbers, plus and minus. My first one multiplies by itself. That's that first one squared. My last one multiplies by itself. That's that last one squared. And my middle 2 terms cancel each other out. That is the special case here. Okay?